Hello friends, Satyendra here, and in this video, let's animate the screw jack. And to animate the screw jack, first you complete this assembly, and for that you can watch my screw jack assembly video where I have done the entire assembly starting from each individual parts. Now once you complete your assembly will look like this. Now to animate any assembly, we mainly focus on three things. The first one is static constant to dynamic constant, the second one is applying the connection, and the third one is applying the motor. So these are the three things we initially do to animate any assembly. So in Creo Parametric, when you assemble any part, you have two different type of assembly constant. The first one is static constant and the second one is dynamic constant. So generally we go for static constant to create assembly, but if you want to animate your assembly, then you must use dynamic constant. Now when you go for dynamic constant, you have several options inside this. So if you see the first constant, rigid, this is used when the part is not having any motion, it is completely fixed at any location. Then the second constant, pin, this is used when your part is having only one motion, rotational motion. For example, your table fan, where the fan blade only rotates, it doesn't move forward and backward. Then the third constant, slider, this is used when your part is having only one motion, sliding motion. For example, the piston head, which slides upwards and downwards inside the housing. So the piston head doesn't rotate, it only slides upwards and downwards. Then the next constant is cylinder. So this is used when your part is having two motion, sliding plus rotation. So the best example is the nut and bolt assembly, where the nut rotates and moves onto the bolt. And likewise you have several other options, but here for this assembly we will mainly focus on cylinder, because for screw jack assembly the spindle rotates and due to the rotation it moves upwards and downwards. So the same part is having two motion, sliding with rotation. So just for recap, so whenever we animate any assembly, we mainly focus on three things. First one is from static constant to dynamic constant, second one is applying the connection, and third one is applying the motor. So let's start with first one, static constant to dynamic constant. So seeing this assembly, I know that I need to change the constant for third part from static to dynamic. So let's edit this part, go to placement and edit this entire constant, and then go for dynamic constant and select cylinder, move this part this side, then select this surface with this surface. Then the second constant, which is transition, which is from this surface to this surface. So you just change the static constant to dynamic constant for the screw spindle. Now if you go to drag component and drag this part, you can see that this part is having two motion, rotational with sliding. Now I'll take one snapshot for this initial position. I will name it as start. So now my assembly is ready for animation. So go to application, mechanism, and once again go to drag component, and you can see that same motion. But here one thing you will notice that there is no link between these two motions. These two motions are completely independent. So the first thing is done. Now the second thing is applying the connection. So once you apply the connection, these two motions will be linked with each other, and for that we have connections. So we have several connections here, but I'll go with the gear connection because this connection is a gear type connection. Now here you have three options: gear 1, gear 2 and properties. So I'll go with gear 1 and I'll select this symbol. Now here you need to enter the pitch circle dia of the screw spindle. So this is 34.5 because the internal dia of the thread is 31 and the pitch is 7. So 31 plus half of the pitch will become 34.5. Now the gear 2. So there is one more symbol here, this symbol. So this is gear 2. Now in properties, you need to enter the gear ratio for gear 1 and gear 2. So by default you have this value, but you can change it to user defined. So here I will enter 7 because the pitch is 7. Now once again go to drag handle. Now this time you will see that there is a link between these two motions. So now if I rotate it, it is rotating plus moving. So now the second thing is done. We have applied our connection successfully. Now the third thing is applying the motor. So practically in our workshop, we rotate this spindle by our hand. So it will be manually rotated. But here in Creo Parametric, you need to use a motor to rotate it. And that is why the third thing is applying the motor. So let's apply the motor. Select this symbol. There are two symbols. Be careful about this. So once you select it, you get other parameters highlighted here. So first you change this angular position to angular velocity. Now the motor velocity is constant. And here I will take 45 degree per second. Now if you go to the graph, you have a constant velocity graph here. So you have successfully applied the motor, and that is why you are getting this symbol. Now once again go to the motor and edit this motor parameter and flip this motor direction and say OK. So the symbol will flip. So all three things are done. Now let's play the animation. Now here you first change this position to kinematic. This time let it be 10 seconds. Go for snapshot and you will automatically get your created snapshot. Now just go for run and your spindle started rotating. But if you see here, the time frame is very small. So let us increase it. So first I will click to this symbol to bring this assembly to initial position. Now I will change this time frame to 100 and just say run. Say yes and your spindle started rotating once again. Say OK. Now you go for playback and run the animation. First you increase the speed and select this symbol, deselect this symbol and run it. So your spindle started rotating and moving nicely. But one thing you will notice here that your spindle motion is all of sudden. So it suddenly starts rotating and it suddenly stops, which is aesthetically not right. It should start just like your table fan. So when you switch on your fan blade first start and gradually the speed increases. Then after some time it will run constantly, and when you switch off your fan, it will gradually decrease the speed of the blade and then it stops. So this is the motion we need for this spindle. So let's understand why this is happening. So for this we will once again edit the motor. So when you edit the motor and go for profile detail, you can see that your motor velocity is constant. So when you have your motor velocity constant, it will rotate all of a sudden, it will stop all of a sudden. So to change this motion, we have several options here. Each option will give you different motion. So to get my required motion, I will directly go to the table. Now here first I will create 4 rows, just like this. Now first one will be 0, 0, second one will be 10 second with 45 degree per rotation. Then the third one will be 90 with the same 45 degree per revolution. And the fourth one is 100 with again 0. So now if you go to the graph, you will see this graph. So it starts from 0 till 10 second, it gradually increase, and then it is constant till 90 second, and then it gradually decrease till 100 second. So this is the motion I need. Now let's update the animation, and for this you edit it, and here these things you let it be as it is and just go for run. Say yes. Now if you see, your spindle gradually increase, then constantly rotates and then gradually decrease, but it is going out of the body. So let's make it 50. Once again run it. Say yes. So the time length is okay, but again it suddenly got stopped. So once again we need to edit the motor velocity. So there the time length is up to 100 seconds and here we are using up to 50 seconds. So let's change the motor time length. So edit this motor, go to profile detail, and here this is 100, make it 50. This I will make it 45 and this I will make it 5. I'll say OK. Now once again update this animation. Just say run, say yes. So this time it started smoothly and then it is constant and then it ended smoothly. Now go to the playback and play this animation. So select this icon, deselect it, speed up and play it. So now it started smoothly, it is going constantly and it is stopping smoothly. Now if you select capture, you can convert this into video. So here you have different formats, here you have different resolution and here you have different frame size. So once you say OK, it will start converting this animation into a video. And this completes the screw jack animation. So this is how we animate the screw jack in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.